What is rotational motion in App Physics 1? Have you ever wondered how objects spin and rotate? In the world of physics, this fascinating movement is known as rotational motion. In the Advanced Placement Physics 1 course, understanding rotational motion is key to mastering the subject. Let's break it down in a way that makes it easy to grasp. Rotational motion involves the movement of an object around a fixed axis. This means that instead of moving in a straight line, the object is turning in a circular path. One of the first concepts you will encounter is angular position. This is simply the angle through which an object rotates, and it is measured in radians. Next, we have angular velocity. This tells us how fast an object is rotating and is expressed in radians per second. It's like measuring how quickly a merry-go-round spins. Alongside this, angular acceleration measures how quickly the angular velocity is changing, which is also expressed in radians per second squared. To understand these concepts better, you will come across some important equations. For instance, the equation that relates linear velocity to angular velocity is v equals omega times r here. V represents linear velocity, omega is angular velocity, and r is the radius of the circular path. Another key equation is L equals E omega, where L is angular momentum, I is rotational inertia, and omega is angular velocity. This equation shows how an object's rotation is influenced by its mass distribution. The last equation to note is tau equals E alpha. This tells us that torque, which is the force causing the rotation, is equal to rotational inertia multiplied by angular acceleration. Speaking of rotational inertia, this concept is essential. It depends on how mass is distributed relative to the axis of rotation. Different shapes have different rotational inertias. For example, a hoop has a rotational inertia of mass times radius squared, while a solid disk has a rotational inertia of 1/2 times mass times radius squared. Understanding rotational motion is not just theoretical. It has real-world applications. Think about how car wheels rotate or how a spinning top behaves. These examples show how rotational motion affects everyday life. When preparing for the Advanced Placement Physics 1 exam, focus on applying these concepts to solve problems. You will likely encounter questions that ask you to calculate angular velocity, angular acceleration, and torque. Practicing these types of problems will help you feel confident on exam day. In summary, grasping the basics of rotational motion is vital for success in App Physics 1. By understanding angular position, angular velocity, and the key equations, you will be well prepared for the exam. So, keep practicing and applying these concepts to real-life scenarios to solidify your knowledge.